Math is good all the time. Now we're going to start off with some relationships between two variables. Instead of proportional relationships, they're going to be linear relationships. Specifically, I want to start with our section 5.2. We have this scenario where we have these cups stacked up, and earlier you were asked to examine the heights of the cups. And now they've actually given us the count. So they say we have 6 cups here and we have 12 cups here. This height right here is getting recorded as 15 centimeters, and this height right here is getting recorded as 23 centimeters. And they're basically asking, can we go all the way up to 50 centimeters? Before I go there, I actually want to make a table and examine this relationship with these cups stacking. So in my table, I would like to track my cups versus my height. If we want to give these guys variables, this would be an x and a y. And if I wanted to give them units, this is just a count of cups, and this one I believe is centimeters. All right, with all those extra things out of the way, let's go ahead and put our count in. So I have 6 cups, and that amounts to 15 centimeters. And then I have 12 cups, and that amounts to 23 centimeters. Now, previously, we had been able to divide across these. So I would be able to do 15 divided by 6, and that's the same thing as 23 divided by 12. And I just want to confirm that that is not correct anymore. This no longer works. So let's try these failed proportional relationships. So 15 divided by 6 is something, and 23 divided by 12 is going to be something different. And when I run those, let's do a 15 divided by 6, get a 2.5. That's a nice ratio. And 23 divided by 12, well, that is a very challenging decimal. Oh, we got a bunch of 666 and then a 67 there. Okay, so these are not the same. These are not proportional. Running out of some space there to write. Now, in order to examine this relationship, we're going to have to go back and look at the change in your x and the change in your y and keep those consistent. So I might want to see how much did this change here. I can call this my rise or my change in y, and this could be my run or my change in x. So to get my rise here, I would take 23 minus 15. I think that's 8. So 23 minus 15, that indeed is 8. So I know my rise is 8 centimeters. And then my run here is going to be 6 cups. So I know my constant of proportionality, or my slope here, will be my rise divided by my run. That will be an 8 centimeters divided by 6 cups. If we go ahead and put this in a calculator and boil it down, we can actually see how much it's going to be for each cup I add. So if I take 8 divided by 6, I get a 1.33333, or 1 1/3. So I get 1.3333 repeating. That's centimeters. And I still need to be over something, and it would be over cups, but this time it would be 1 cup. So each cup, we could say this in a sentence, each cup adds just 1.33333 centimeters. So basically, if I wanted to see how many I get overall, let me zoom here, how many I would get for 50 centimeters, We could just keep going. There are different tricks that we could do this, but I want to save our answer here. This question, we're actually going to save until after we're done with our graph on the other side. Now, there are different tricks we could do. We could see like, oh, maybe how many 15s go into 50. So 50 divided by 15. We could see, well, that doesn't work great. It's close. It would be close to double this. So you feel like it's double that. But let's check on the graph. Let's check on the graph. All right, on our second page here. If you didn't create your own graph of the situation before, let's do so now. So let's remind ourselves we had an X and Y pairing. So I believe I had a 6 and a 15, and I had a 12 and a 23. So go ahead, find that on your X and Y. So my 6 would correspond to here. This is a 6. And my 15 is 10, 11, 12, 13, 14, 15. 15 is right there. These guys go through here. And I put my dot right there. So I have 6, comma 15 on the graph there. Then let's put the 12. So my 12 would be 11, 12 right here, and 23 would be 3 up from 20. My 23, and these guys are going to check out right here at 12, comma 23. I can highlight these. It's zoomed out a little bit, so it's hard for you to see. These right there are my 2 points. Now, I'm trying to see if my ruler is around. Looks like my other ruler is gone, so we'll have to use this one, which seems a little reflective for the camera. But we can connect these, and we can make ourselves a graph, a line that's going to plot our predicted cup growth. As we add cups, we can see how far we would go. Now, the question on the other side had a 50, and I can't remember if it was a 50 cups or 50 centimeters. So let's go back and review the other side. So it was asking, how many cups are needed for a stack with a height of 50 centimeters? So let's go ahead and locate where 50 centimeters is going to be on our graph. On this side, my 50 centimeters is right here. So I can take this all the way across and see where do I hit my line. So I'd come right down here like so, and it looks like my answer is going to be right there. So that's 2 past 30. So I would say 50 centimeters links up with 32 cups. And we could put this on my table here. So I say, hey, I think that 50 centimeters links up with 32 cups. Does that seem to have the same slope? Like on the other side, we found that our slope was, I think it was 1.333 centimeters, 1.333 repeating centimeters per cup. And so here on this side, let's see if that's the same thing that we get when we find the difference between these. Now, this difference looks like 27 to me. I'll have to double check that. And this difference here looks like 20. Okay, so I have 50 minus 23. So I take 50 minus 23. That's 27 like I thought. And then I take 32 minus 12. And that's the 20 like I thought. So let's take these two and divide each other. And I should be close to that 1.33333 that we had before. So let's do a 27 divided by 20. And I have 1.35. That's pretty close to 1.333333. So 1.35 is my slope that I find between these 2 points. So really my slope is staying consistent here. It's not perfect because I'm not graphing perfectly and I'm guessing where it touches. Could have some decimals. Okay, let's examine our questions here. What are some of the ways to tell that the number of cups is not proportional to the height of the stack? Well, number one, we already tested that out. Right here. When I divide my y divided by my x and my y divided by my x, these are not the same. So the proportionality, when you divide across your table, dividing across the table fails to give the same proportionality. Now this is the first thing. Now let's double check here. So checking my slope, I have a slope of 1.33333. Is that close and consistent to my slope that I found on this side, 1.35? These numbers are fairly close. I think those are reasonable, okay? Now, these numbers up here, less close. These are my proportionality fails, 2.5 and 1.9. Those are pretty far off, especially given the size of those numbers. So this fails with a constant of proportionality. I think it also fails because the line does not go through 0, 0, in other words, the origin. Okay, so my line does not go through the origin. If it doesn't go through the origin, I know that it's not proportional. Now, what is the slope of the line in your graph? What does the slope mean in this situation? Well, we've actually found 2 different slopes so far because we're exceptional scholars. We found a slope of 27 divided by 20, which was a 1.35. We also found a slope of 8 divided by 6, which was a 1.333333 repeating. What does slope mean in this situation? We need to think about our units when we do that. So my rise is counting the height, and my run is counting the cups. So that means that slope is the height per cup. That's how I like to think about slope. And when we get further on in this unit, you're going to notice that the word per, maybe the word every, maybe the word each, all of these are hints that a slope is coming. Okay, so height per cup, height every cup, height each cup, that's going to happen. Now this one, at what point does your line intersect the vertical axis? Now my vertical axis, this is the y-axis. Okay, so then that seems to cross right here. And that seems to be at 1, 2, 3, 4, 5, 6. So it seems like I cross at 6 centimeters, which oddly enough is the same as 0 cups. Now, when we did it in class, I actually started my ruler. My ruler didn't really start at 0 here. But if you notice, 6 cups seems to be the bottom of where these lips actually are. And so really when I'm adding a cup, I'm only adding an extra lip. And each lip here we just found was a 1.3333 repeating. So I kept adding on 1.333, a 1.33333, etc. as I add these additional lips on. Okay? So this right here, that seems to be the 0 point. We're tracking the additional parts that are getting added on. All right, I encourage you to read through the summary and then go ahead and give your practice problems a try. Good luck, and again, math is good all the time.